Hello everyone and welcome to today's webinar, Remote Continuous Monitoring with Ultrasound. It's brought to you as a part of CBM Connect. I'm Kim Fuger, the manager of Mobius Connect, and I will be your moderator for today's session. First, I'd like to introduce today's presenter, Graham Fonseca from UE Systems. And before we get started, I'd like to review some important information with you. This webinar is being recorded and you will be emailed the link with the access to the on-demand version of this webinar tomorrow. The recording of the webinar will also be shared on CBM Connect, so feel free to pass it along to your colleagues if they aren't able to join us today. Mobius Institute is a worldwide provider of reliability improvement and condition monitoring education dedicated to supporting plants and helping them become more safe and successful. Mobius Institute's key advantage is its unique training style that features innovative 3D animations and simulations, making complex topics easier for you to understand. The Mobius Institute Board of Certification is an ISO accredited certification body that provides globally recognized certifications to CBM practitioner and reliability professionals at any stage in their career. To view our global training schedule, please visit mobiusinstitute.com. Next up, I am pleased to share with you Mobius Connect Community Platform. The Mobius Community Connect is all about you, providing you with the space and technology to connect with the right people and resources to help you solve problems, continue learning, and share your experiences too. Once you've created your free profile, similar to how you would on LinkedIn or any other professional networking site, you can start connecting with other industry professionals wherever you are in the world and in any language. Mobius Connect includes fun features like the industry's live feed, forum discussions, interactive connection finder map, direct messaging, customized communications based on your areas of interest, global events, jobs, news listings, and a mobile app, which is available for download in the Apple and Google Play stores. You can also continue your educational journey live with the Connect conferences or Community Connect groups to gain access to additional resources and attend live or virtual meetups with other professionals in your area. You can get started by creating your free profile and joining the community at mobiusconnect.com. I hope to see you there. And last but certainly not least, today's webinar is produced by CBM Connect, the leading educational community, which is published by thought leaders and experienced industry professionals from all over the world, with a dedicated focus on each of the condition monitoring technologies. CBM Connect allows you to organize content based on your areas of interest, like condition monitoring management, alignment and balancing, lubrication, motor testing, oil analysis, thermography, ultrasound, or vibration analysis. You can get started on CBM Connect by creating your free profile over on Mobius Connect and selecting which technologies you'd like to stay up to date with. You can visit cbmconnect.com directly to access hundreds of on-demand webinars, interviews, videos, white papers, and much more. Furthermore, if you are interested in contributing to the CBM Connect knowledge base, please reach out to us during the webinar through the question panel, and we will be more than happy to share some more information with you. Now, it is my pleasure to introduce today's presenter, Graham Fonseca. Graham, are you here with us?
I am, yep.
Well, fantastic. So for those of you just joining us, welcome to Remote Continuous Monitoring with Ultrasound. If anyone does have any questions throughout the webinar, go ahead and type them in the panel of your GoToWebinar screen. And at the end of today's session, Graham will be more than happy to answer your questions. Your questions will be aired anonymously, so no need to feel like you're going to get called out. If we do run out of time and don't make it to your question, Graham will reach out to you directly after the webinar to make sure that your questions have been answered. All right, Graham, I'm going to go ahead and pass the presentation over to you now.
Awesome. Thanks so much. So yeah, appreciate everyone joining today. What we really want to focus on is remote monitoring with ultrasound, and more specifically, just how easy it is. So simply put, ultrasound is the most versatile and the easiest technology for predictive maintenance. Now, I'm not trying to say that it's the golden bullet, but you can use ultrasound in a multitude of applications, right? And in each of those applications, it's just incredibly simple to understand. And simplicity is so important as we head towards Industry 4.0, or in other words, just smacking sensors on everything. The reason being, ultrasound is an easily digestible technology in a world where we're just overwhelmed with complicated data. So I will ask, and we've got our first poll here, Kim, if you're ready for it. Are you guys currently using ultrasound? So I believe you guys should see a pop-up, and we'll just wait here for the answers before we move on.
Perfect. Yes, everyone, there is the screen in front of you. If you guys can either hit yes or no directly on the screen, we will record your collections here and give it just about another 30 seconds. Okay, Graham. So we have 61% today saying yes and 39% saying no.
Oh wow, that's interesting. Typically it's around 50. So that's awesome to see that a lot of our users here are using ultrasound. And what I'll do for those that are not, or those who may be a little bit less familiar with it, is discuss a little bit out of the background of ultrasound. So with ultrasound, we're detecting sounds at a frequency much higher than you can hear at, and we're measuring two main things. So the first is friction. Now, when we're talking about bearings, when you have friction, that's not a good thing, right? So that's why ultrasound is that ideal technology for bearing health and lubrication. Now, the second one is turbulence. So if we have something that's at a high pressure and it wants to move to a low pressure zone, the example I always give is, when you put your thumb over a hose and that water stream just shoots out, that will create turbulence. And it'll also create a sound that's detectable by ultrasound. So in an industrial application, the most common applications we see are valve and steam trap leaks. Now, in both scenarios, all we're doing is we're just measuring the difference in noise. And in its simplest terms, if noise goes up, we got a problem. Now, ultrasound has four main applications, the first being leak detection. So we're talking compressed air or gas and vacuum systems. Now, we're detecting turbulence, but in this scenario, we need to use an airborne sensor rather than a permanently mounted sensor. The second is our fastest growing application, which is bearing inspection and lubrication, where we're measuring that friction that we talked about. The third is our electrical inspection, which also requires an airborne sensor. And then finally, we have steam traps and valves where we are measuring the turbulence that we discussed. So the two main applications we'll discuss are both the structure-borne ones, so the ones with permanently mounted sensors. So with bearing inspection, we're addressing two main questions. When is grease required and how much grease is required? Now, friction is our guiding principle for these two questions. And although this is an ultrasonic sensor, to make it simple, we can just refer to it as a friction sensor, right? Friction goes up, that's bad, and the sensor tells us exactly when that occurs. And as we start to grease, the friction will decrease, which is good, and the sensor will tell us when to stop. So it's quite simple. And similarly, for steam traps and valves, we can simply call this a turbulence sensor. So if we're discussing predictive technology with someone who's familiar with valves and steam traps, the word ultrasound might not register, right? I don't know what they might think. Their mind might go to pregnancy, right? I don't know. But if you were to call it a turbulence sensor, that might be that aha moment that we need, right? And ultrasound is simple and versatile enough that the name can become interchangeable with the issue it's detecting. And funny enough, that's what we often see. Sorry, there we go. Okay, so typically there are two shortcomings of ultrasonic sensors, right? And that being sensitivity and measurement range. Now, the easiest way to think about sensitivity is that at a given frequency, there's a point at which an ultrasonic sensor will no longer be able to detect noise, right? So that's how you can think of sensitivity. What is that smallest detectable change? Now with traditional sensors, we have to adjust the sensitivity. And for those familiar with our 750 sensors, the process was quite challenging, right? As you have to tap one of those 7 wires to ground to decrease or increase the sensitivity. So quite a cumbersome process. Now the issue here is, let's say you dialed that sensitivity up on a quiet bearing. Well, when it starts to fail, the noise or that friction level, it now exceeds that sensitivity range. Now the other consideration is that measurement range, right? Which is often designed right into the sensor. So typically this range is quite small and it cannot be changed. And that's for all existing ultrasound sensors that we're aware of. Now there are some sensors that cannot detect both a healthy baseline and a critical failure warning because that range is too small. So typically we're forced to play a game between adjusting sensitivity and adjusting the measurement range, which is not a fun game to play. So to address these shortcomings, what we've done is we've developed our family of 850S sensors. So no sensitivity or measurement range adjustments are required. And we have this family that addresses that, right? So first we have our low and our high speed friction sensors. Now, I know a question we'll get at this point is, well, what RPM do we choose, low versus high speed? And the answer really is, it depends. So it depends on the load, on the application, on the environment. In a perfect theoretical world, speed should actually not have an effect on the noise or the friction level of a bearing. But we don't live in that world. We live in reality where speed does play a factor. So really the answer is, once we discuss your application, then we can recommend a high or a low speed sensor. And then we have the universal sensor, which is straightforward. It's meant for valve and steam trap leak detection. So we can consider that our turbulence sensor if we would like to. And then the last, we have our cavitation sensor. So with cavitation, when the pressure drops below the vapor pressure of the fluid, vapor bubbles will start to form, right? And then when the bubbles collapse, they can damage the pump. Now with the 850S, we'll be able to detect that cavitation when the bubbles are forming rather than when they're collapsing or when the pump failure occurs, right? So you're getting that early detection prior to failure. And that's a family of 850S sensors. So instead of having to adjust the sensitivity, we just pick the right sensor for the right application. And even within those applications, this smart sensor will actually auto adjust the sensitivity for peak performance. Now this sensor, if needed, can detect anywhere from 0 to 100 decibels. So that measurement range issue is no longer a worry. And then the last thing, it is stainless steel, it is water resistant, it is dust proof, so it is quite a robust sensor. And very briefly, the way you would mount it is you would clean the surface that you're mounting it on. So typically, a bearing housing or a pipe. So you prepare that mounting surface. You would push this mounting kit in until it clicks. And what that does is it holds the kit in place until that epoxy dries, rather than you having to hold your thumb on top of the actual kit itself. And then after 15 minutes, you would just pry off that little plastic piece and you're left with a mounting stud. And you would just thread that 850 sensor into that stud, and then you connect the cable. So it's simple enough. And for those that are using the 750, you may remember wondering, why in the heck are there so many wires, 7 to be exact, as I previously referenced? Well, with the 850, again, we're focusing on simplicity. So it is quite simple. And if you show this to any automation person, they'll understand exactly how to install this into any PLC, DCS, or IoT device, including our OnTrack, which we'll discuss in a bit. And they probably won't even need an instruction manual, to be honest. So I want to get into the applications that we discussed. So the first is our valve and steam trap. So let's consider this application where we have fluid flowing through a pipe and a valve controlling that flow. So a pretty typical application. In this picture, the valve is seated, right? It's working great, we're all good to go. But imagine if over time, there's some wear and tear on that seat and the valve starts to leak. Again, common enough that we do have to worry about it. So now we're going from that high pressure on the left side of the seat to that low pressure and high velocity on the right side of the seat. So remembering that hose analogy, right? So what's happening is we're creating turbulence. So if we have that sensor on the right side of the valve, we can measure that leakage, right? If we're given a dB value from that sensor, and if it does not line up with our normal operating dB values, we know that we have a problem. And the best part is we can send that signal to any system that accepts a 0 to 20 milliamp signal. So I want to take a look at typical valve behavior. And this is a test we did with our ultrasonic sensor. So we had air flowing through a pipe. I believe it was about 90 PSI. And we measured the decibel level on a diaphragm valve when it's closed versus when it was open. So when it was open, the decibel was hovering around 50. And when it was closed, it was hovering around 0. And what's really important is when it's at or hovering around 0, it isn't exactly 0. And the reason why that makes sense is because there are other things that are happening downstream or upstream. The pipe could be shaking to create that noise. So it's normal that we aren't going to be exactly at 0 when the valve is closed. So what we did next is we actually took some sandpaper to the valve seat and we scuffed it up. And as you can see, we barely did anything to it. So it's probably similar to what you would see over time from wear and tear. So that blue line that we have on the graph, it's still that valve open, and the orange line is still that valve closed, but the gray line shows the leaky valve. So very simply, if the valve was supposed to be closed and we see a dB value near 40, we know there's a leak, right? So there's two key takeaways here. The first one being that more data is not always better, right? Insights is what we want. And if we can get to the same conclusion with a simple decibel, rather than having to analyze waveforms and frequencies, that's just gold, right? It just saves everyone time and effort. The second key takeaway is that we need consistency in this program. So in this example, there's not a magic number that tells us that the valve is leaking. We need to have an understanding of the noise level when it's closed and then when it's open before being able to gain insights. So these successes and these wins will come down the road, right? It's not, as soon as you install it, you know what's going on. Now, using a real world application with that same exact diaphragm valve, I want to showcase this trend on the right here. So here, the dB level when open is around 40. And in this scenario, because of an incredibly noisy environment and operational context, the closed dB level was actually around 20. So if we recall, the closed dB level in a test environment was around 0. In an operational and a real world environment, it's actually around 20 in this scenario. So circled in blue there around that 1756 mark is when we noticed the valve was leaking, right? That closed value actually shot up to the high 30s. Now, again, we made accurate conclusions with simple data and rules, right? With that rule being turbulence increase equals bad. Simple enough, right? And again, without trending over time, we would not have known that 20 dB signified a closed valve, right? So, and we would have, we wouldn't have known that the valve was healthy. So without context, you may think there's a leak from the get-go. So again, focusing on that program consistency and sustainability. Now I'll show you a quick steam trap example here. And in this picture, there's 3 steam traps. So we took a trend from one of the 3. Now you may also notice that we have the sensors mounted on our isolation yokes. And that's because the temperature of these valves are very hot. So it's just a heat sink, which is a physical metal piece that goes in between the sensor and the actual pipe itself. So with this example, I wanted to give you an idea of how we would trend a healthy steam trap rather than focusing just on the failures, right? So the first run through, we gather what we believe to be a healthy trend. And the second run, it's overlaid in orange here. So you can see that the second batch may have taken a bit longer, but the amplitude and the overall trend is almost identical, right? So if there were a failure, we would see a drastic difference at some point along that trend, which we don't actually see. We just see the trend shifting rather than there being a major difference in amplitude. Okay, so what we want to do next is take a look at our fastest growing application. So why is this important? Well, a lot of experts on this call would already know that a huge majority of bearing failures are related to lubrication. So as I mentioned, we can use that friction sensor to tell us when and how much grease is required. It's incredibly simple, just like the rest of ultrasound technology, right? We're outputting a decibel level and a timestamp. We're not outputting a spectrum in this case. We're not outputting noise files in this case. It is just a simple decibel value. And if that value increases, that means that friction is increasing, right? Which tells you you need to lubricate. So you can also bring this data into your own system or trend it on our OnTrak system, just like with the last application there. And when we talk about the reason to measure friction, well, the entire point of an anti-friction bearing is to reduce that friction. So if we can start to get that friction value into the hands of reliability and maintenance people, the operations team, right, and they can understand when there is poor lubrication, friction, or impacting, man, is that going to help with that early detection of failure? Now, it's not going to give you a detailed analysis, but it is that early indication of failure. And so in order to understand this a bit further, I'll explain it in the context of the OnTrak. So what we would do is mount our sensors to the bearing. They'd be wired back to the OnTrak. We'd also have our lubricators mounted to the bearings and wired back to the OnTrak. Our OnTrak would be communicating over cell, Wi-Fi, or Ethernet to our UE Insights cloud, or it could be communicating with your PLC as well. And in either case, you'd get that alert eventually when a bearing does require lubrication. And you would look at, anywhere where you have internet access, you'd be able to look at your laptop, your phone, your tablet, wherever it is, and you'd eventually get that alert that says, hey, bearing requires lubrication, right? Eventually, no matter what, friction is going to rise and you're going to need to lubricate. And what you would do is either using our manual mode or our assisted mode, you'd send that command to add grease. And you can send that command from anywhere in the world, right? The other day, I lubricated a bearing in New York at our office, and I'm out in Vancouver, right? So not only across the country, but 2 different countries. So you can remotely lubricate from anywhere in the world. When you send that command, it'll go to those lubricators, and they'll dispense grease. And in an ideal application, in an ideal setting, it'll lower that trend back down to baseline. So we'll go to our next poll here, and it's, are you currently using vibration for online monitoring?
Thank you, Graham. Yes, we do have this one up. We'll give it about 30 seconds. And then, Graham, I would like to go back to our very first one. Somebody did mention in the comments that I think I've already posted the vibration question. So we'll go back to your first one. Are you currently using ultrasound after this?
Oh, okay.
All right, we're still getting some questions in, so I'll give it a couple more seconds.
Sounds good.
Okay, for this one, we have 56% of people saying yes and 44% saying no.
Okay.
And then, yes. 1 second here. And then if everybody will just take another moment to see if they are currently using ultrasound. We'll see if we get close to the same number.
Yeah. Hopefully a few more percentages there after the first half of the presentation.
Yes, well, you will be very, very surprised. We are now at 64 saying yes, so we only went up 2, and then 38 saying no. So no, we did not change too much. Yeah. But again, for the people using vibration, it was 56% of our group saying yes and 44 saying no.
Right, okay, and that's about typical. And so what I want to do for those that, again, do not use ultrasound, I just want to explain how simple this ISO standard is and how we alert no matter what bearing it is, right? And we're specifically talking roller element bearings, right? But the first step is trending that baseline. So you want to put that sensor on, trend that baseline. So again, this is not a magic solution, right? We do need that program sustainability to make that work. But once we have a baseline, it becomes quite simple. An 8 decibel increase, no matter what bearing, that would indicate a lack of lubrication. 16 decibels above baseline, that would indicate a failure mode that's potentially beyond lubrication alone. And then 35 dB above baseline, that is a point where you need to get your butt out to that bearing fairly quickly, right? Because you're about to fail. So those are the 3 alarms that we would trend and give you notice on. And so this is what you would see in UE Insights for a healthy bearing. So that blue squiggly line, that's actually 1 data point every single minute. But because of the x-axis there, and because we're expanded over time, it just looks like a line. But that's an example of a healthy trend where the delta between the lowest and the highest dB is not very big, right? And we're consistently hovering around 10 decibels. So we can confidently say that this is a healthy baseline. So what we would do is we would set the baseline at 10 decibels after trending for a period of time. And that's, you can faintly see that green dashed line behind that blue squiggly line there. And then we would set our alerts. So 8 decibels over baseline is that blue dashed line. 16 decibels over baseline is that yellow dash line. And then 35 decibels over baseline is that critical failure, that red dash line there. And here's an example of an unhealthy bearing where that dB level is up above baseline, right? And then we applied grease remotely through UE Insights, and the dB level decreased, as well as, if you notice, the actual delta between the lowest and highest decibel level, that decreased as well. And what's really nice about this is the data is so simple but so meaningful, right? It is so obvious when a bearing needs grease, right? We could, if we wanted to, even call this a grease sensor, right, rather than a friction sensor. Now, conversely, here's an example of over lubrication. So we actually had a customer, they were using just auto lubricators and they were doing time-based lubrication, right, based on manufacturer recommendations, based on the size of the bearing, the speed, the load, all that, right? So they did all their calculations, but they still believed that they were over greasing. So they came to us, they came to UE Systems, and they wanted us to prove that they were over greasing, right? So in order to prove this, what we did is we threw our friction sensor on, and we saw that after greasing, the friction level actually increased. Now, in this scenario, it eventually came back down, and that, you know, potentially could have been because the grease leaked out of the bearing housing. But that increase in decibel level after greasing, it told us all we needed to know, right? You'll also notice that the temperature reading, it didn't pick up a thing. You can see that temperature reading on the graph as well. And with ultrasound, we were able to prove that time-based lubrication was actually causing the over-greasing of bearings. So we'll go to our next poll here, Kim. How would you rate the success of your current online monitoring solutions?
All right, thank you. This one is launching. Now this one is on a scale of 1 to 5, with 5 being your best. All right, we still have some submissions coming in, so we'll give it just about 30 seconds. All right, so I do have the questions of this one coming up, Graham, because we're kind of split a bit in some areas. We have 5% saying number 1, so it is the least, 11% saying 2, 45% saying number 3 in the middle there, 16% 4, and with the highest, we have 23% of people.
Oh, wow. Sorry, and what was 5?
So 5 is being the best. So on the scale, how do they rate their current online solution monitoring solutions?
Yeah, sorry, what
23% say super high.
Oh, wow, that's incredible. Okay, well, for those that are 5, this is I don't know if we can improve above the 5 out of 5 here, but we'll sure try. What's really interesting, and I'd love to talk to everyone that rated a 4 or 5, because this 2021 predictive maintenance study done by Plant Services, it showed that there's an ever increasing readiness for proactive programs that engage in that predictive and that prescriptive maintenance. So what I would bet, and I would bet a whole lot of money on, is that everyone who is at that 4 or 5, they're very likely using that predictive and prescriptive maintenance, right? And it's no surprise that that program satisfaction has trended steadily upwards from a low of 35.1% in 2016 to this year's high of 53.4%. And we're even seeing that in this survey alone, right? Whereas if we were to do this survey last year and trend it back in time, we'd probably have more attendees voting on the lower end from 1 to 3 versus 4 to 5. But as there's an uptake, if we try and connect the dots here, as online monitoring increases in PDM programs, program satisfaction has steadily increased along with it, and there's a very, very consistent trend. So I do like the high ratings there, and that's in line with what we're seeing in the industry as there is an uptake here. Oops. Sorry, I keep clicking here, Kim. There we go. I'm good. The last poll here. So do you have any application ideas where you could see ultrasound benefiting you?
All right, thank you. This one is shared. We are getting some responses in. All right, just about 30 seconds more. There's quite a people still answering. All right, for this question, we have 86% saying yes and 13% saying no.
Yeah. Okay, and overwhelmingly yes, which is great to hear. I'd actually be interested in talking to everyone. For those that say no, I'd be interested in hearing why not. If it's maybe not the right time, or if their reliability program is already at that 5 level, then maybe that's the reason. But it would be interesting to talk to everyone about it. So whether you did say yes or no, I'll just leave this email up on the screen here, and if you do want to discuss further, whether you want to discuss an application or discuss even why you think it's not for you or not for you right now, my email is up here on the screen, so feel free to shoot me an email. And what we wanted to do today as well is just leave plenty of time for questions and discussion, so I'll hand it over to Kim for that portion of it.
Thank you. Sorry, I did forget to unmute myself. So it is time for the question and answer session. If you do have any questions, please go ahead and enter them now in the question panel of your GoToWebinar screen and submit them for Graham to answer. Again, your questions will be aired anonymously. If we do run out of time today and don't make it to your question, Graham will reach out to you directly after the webinar to make sure your questions have been answered. All right, Graham, one did come in while you were presenting, and I know I saw it on the DB slide that you have, but they're saying with the DB, with respect to what question? Is 0 equal DB, or does it equal something different?
Yeah, so okay, with respect to, so I think I know where this question is coming from. So that dB is always with respect to that baseline. So the dB is our decibel level. That's what we want to trend when we install this sensor. And so the tricky thing is, when we install a sensor, it's not always going to be on a brand new bearing. So it's not always on something we can consider as healthy. And even in certain scenarios, if we do install the sensor on a brand new bearing, sometimes that bearing is overpacked with grease, right? And so sometimes it's not healthy off the bat. So basically, we never want to just assume a bearing is healthy. And in most cases, we actually can't assume that. So what we want to do is install the sensor on that specific bearing that we're monitoring, trend that dB level, that decibel level, so essentially that friction level over time, and see if we consider that to be healthy. And there's some things that can tell us that, right? If the dB is hovering all over the place, then we already know it's not healthy. If it's not consistently at, at or around a specific number, we can say, you know what, this bearing is not healthy enough. We want to, set it into an alarm off the bat. Or if it is healthy, we know what the baseline is, we can set that baseline, and all those alerts are in comparison or are relative to that baseline. So the baseline is the only thing that will change depending on each bearing. You can even have the exact same asset, but because it may be a little bit different temperatures, or it may have seen different loads over its lifetime, the baseline may be a different value. So that's why each bearing has its own unique fingerprint of a baseline, right? So once we get that baseline, that's the only thing that changes bearing to bearing. And then the alerts are always with respect to that baseline. So 8 decibels over that baseline, 16 and 35 over that baseline.
Thank you for explaining that. If we do get any more follow-ups, I will be sure to send them to Graham to answer for you guys. This next question coming in is saying, how much training is involved to get up and running with ultrasound program?
Yeah, that's a really good question. So again, because we focus on simplicity, it really is not a lot of training. What actually requires the most input is off the bat to set those baselines. So let's say, for example, we're working with something that's running at different speeds at different times of the day. We want to be sure that we see that increase in decibels and we know, hey, that's actually just an increase in speed, so we can't actually send an alarm out when it's just a VFD changing speeds, right? So those are the types of discussions we have with the user prior to setting the baseline. But other than that, it's very simple to learn, and it's not. We have 1 hour long training session to get you up and running on UE Insights, and that's typically more than enough. And most of that time is actually more so discussing the application rather than it is learning ultrasound, because it's so simple, right? It's literally just, did it increase over that baseline? How much did it increase? And you'll get an alert. You don't need to consistently watch it and log into UE Insights every single day, waiting for those alerts to come up. You'll get an alert sent to your email. It'll tell you when that failure is already occurring, or tell you when to lubricate. So it's very prescriptive and tells you exactly what to do. And then you're good to go. And if you're not using UE Insights and you're trending, steam traps or valves, again, the same exact idea. We just trend that baseline, and then is there an increase over that baseline? If yes, let's get you an alert and go out and inspect it, right? So it's important that this is that early detection of failure, right? And it's because it is simple. The one caveat is we can't do that full analysis. We can't say, this is a specific inter-race bearing failure, right? But what we can do is tell you, when something is wrong, and tell you to go look at it just based on that simple increase over that baseline.
Great, thank you for that. This next question is asking, what makes ultrasound better than typical vibration accelerometers?
Yeah, that's a really good question, and I don't necessarily like to compare the two. I don't think one is better than the other, right? They both have their own uses, but the difference is typically what you see is ultrasound will detect friction earlier on that P to F curve. So that's typically what we see. But the main thing and the main difference between ultrasound and vibration is just that simplicity. And that's what I wanted to focus on today is, all you need to know is, did that decibel level go up? If so, that's probably bad. Let's go take a look. And with ultrasound, you can use spectrums and you can analyze and you can look at waveforms and analyze the noise, right? You can do all that. And that's where our handhelds come in, and that's where you want to go to deep analysis. But in terms of that remote monitoring and that 24/7 continuous monitoring, it is simple. And that's where the advantage is, right? In that simplicity over vibration specifically.
Well, thank you. All right, this next question, I'm trying to scroll back down. We had one come in, sorry. Now they are asking, does the UltraTrak record the sound produced by failures? And I do apologize if I said the name wrong of the product.
Yeah, no worries. So yeah, that's actually a really good question. So currently it doesn't. Currently, if we do want to record the sound, the actual noise of the failure, we would need to use our forecast. So the forecast has been out for quite a while. And really that is the major difference between our forecast and our on-track system, is the forecast is for that deeper analysis. So it is something that you can capture those noise files and analyze the full wave. But obviously that comes at a cost, right? So if we're just talking about that continuous monitoring, that remote monitoring, and we just want to, do balance of plant and monitor all of our bearings, for example, we would use the on-track. Whereas if you have, a critical asset where you want to capture those noise files, you may look into something like the forecast. Now, at the end of the day, if you're detecting that early failure, the on-track is where you want to focus, right? Because it'll just give you that indication, and you can go out and analyze further with, let's say, our ultra probe or even vibration, right? So I would say, the ULTRA-TRAK is where we're heading with online monitoring for sure.
Thank you. This next question is specifically talking about the on-track smart loop, and it's saying, is it exposed to temps, below 30 degrees Celsius? Would it stop working entirely, or does it shut down until warmer temperatures rise?
Yeah, that's a good question. So it's currently rated to -40 Celsius, and we do actually have it out in the oil sands in northern Canada, and it's running fine. It's outdoors, and they see temperatures, even below -40. So from our own specs and from practical experience, we have seen that the on-track will actually last in these temperatures. Now the other question is, will the grease freeze at that temperature, right? So that's a different question. But in terms of our equipment that we supply, we know that it can function at those temperatures.
And a follow-up to this one, if would there be an alert if the auto lube stops working?
Yeah, no, that's a good question. So what you would have in UE Insights is an indicator of the level, so that volume level. So you wouldn't have to go out to the field to check on your actual level of grease, and you would get an alert based on that volume level. So what we have as a standard is at 25, 10, and 15%. When you get down to those volume levels, you'll receive a notification letting you know. We can remove or add those alerts or change those numbers around, right? But those are the alerts that you would get. Now, if the actual lubricator stops working, and that's typically going to be a pressure issue, right? Either not enough or too much, that is a local alarm on the lubricator. So how you would see that is in UE Insights. If you try and grease and nothing is happening, and you're trying to grease and you think it's dispensing, but there's no change in that dB level, that would be an indication in any case to go check on that bearing, right? That's how you're supposed to use the program is, if you don't see that change in decibel level, you go check on that bearing to see what's wrong, because it could be an issue. And at that point, you would see that local indicator saying, hey, there's a back pressure issue, or there's something wrong with the actual lubricator.
Perfect, thank you. Now these are great questions coming in.
Yeah,
we do have, a few more minutes to go over some more questions. And this one is asking a bit, increase of noise can come from another source in the case of bearings. I think they are following up with when we were talking about the sound producing by the failures.
Yeah, no, that's correct. So specific to bearings, that's a good point. And the way that ultrasound works is it's directional. So if you have it mounted on that bearing housing, you're right. There's a chance that it could detect noise from elsewhere, but because it's directional, it's not going to have enough of an effect to vary that trend enough that you would accidentally lubricate based on something else going wrong. So that's it versus vibe that may not be directional, right? So that would be how we can be confident in ultrasound, in that it's only going to detect that friction from that bearing because it is directional.
Thank you. All right, Graham, we will wrap it up with one last question here. And this one you might want to take offline, but they're asking, is there any plan to produce, or do you guys have wireless ultrasonic sensors?
Oh, okay. I I love this question. Yes, absolutely. Can I put a timeline on it in this webinar? Unfortunately not. But 100% that we will be coming out with wireless sensors. Yeah, and unfortunately we don't have a timeline on it.
No, great. Thank you. Yes, I know. I think that's one we see, but I'm not 100% certain on the pros and cons of both ways with ultrasound, but some people do like the, wireless on there. So yeah. Thank you for giving us a peek inside the future.
Yeah, for sure.
Yeah. Well, Graham, I did leave your contact information up here on the screen. Is there any other way people could get a hold of you if they wanted to find out more? Are you on LinkedIn, any other social media platforms?
Yeah, I'm on LinkedIn as well. So you'd see Graham, and then my last name is Fonseca, Fonseca. And I'm sure it's in those emails that have gone out as well. The only thing I will say is there are two Graham Fonsecas, and they're both located in Vancouver, British Columbia in Canada, which is funny enough. So just make sure you have the right one that works for UE Systems there. And that's the picture that's on LinkedIn. So if you go back to that screen, Kim.
Well, great. Thank you. Was there anything else you wanted to add today before we wrap things up?
No, that's it. And I look forward to all the emails that come in, and happy to chat about the 850 sensor more and applications, and happy to chat about the OnTrak as well if it comes to that.
Yes, we do have some questions we didn't get to today, but I will make sure to send those over to you for the follow-up. Yeah. And thank you so much for your time and awesome presentation today. On behalf of our entire team here at Mobius Connect, thank you to our wonderful audience for joining us today too. Just as a quick reminder, the recorded version of this webinar will be made available on CBM Connect, and you will receive it in an email tomorrow as well. You can see a full list of our upcoming webinars and other educational content on CBM Connect, and you can visit it directly at cbmconnect.com. If you are interested in engaging with other industry professionals or would like to participate in the industry's live feed and ongoing forum discussions, you can do so by visiting Mobius Connect at mobiusconnect.com. You can also follow us on social media at Mobius Connect to stay up to date with the latest community happenings. And if you have any questions at all, you can email our team directly at info@mobiusconnect.com. Thanks again for joining us. Have a great day. Please stay safe, and we will see you all next time.